Sometimes solving systems of equations using elimination takes a little bit of prep work before we get the evil twins to get things to cancel out. And again, what I mean by evil twins is if I could think about a way to get this y over here to be a positive 4y and a negative 4y, they'll be evil twins because when I add them together, they'll cancel out and then we can kind of move on and just solve for x. So we're going to have to think about numbers that we can multiply either the top or the bottom equation by so that we can get evil twins. And again, if you look here at this minus y, this is going to be a really good setup here to try and get this to cancel with the 4y. And to do that, if I multiply this whole equation up top by 4, this should give me a negative 4y, which will get things to cancel like I want. So what I'm going to do is bring this over. Again, if I multiply by 4, to keep the equation true, I have to multiply everything by 4. So that'll give me 8x minus 4y, that's what I want, is equal to 24. Don't forget, a lot of people forget to multiply that last number as well. So don't forget to multiply 4 to that last number. And then we'll bring down our 3x plus 4y equals negative 2. I'm not going to change this one at all because I've already got the 4y like I want. So I just brought this one over. And now notice, again, we've got the evil twins. The 4y should eliminate or cancel. So now I'm left with 11x is equal to 22. And now from here, again, this is pretty easy to solve. We just divide by 11 on both sides. That'll give me x equals 2. So I'm already halfway there. Just got to find the y now. And I think I'm going to choose, I'll pick the bottom one just for kicks here. So we'll get 3, and I'll plug in the 2 here in a second. I'm just going to bring everything else down. So I'm going to plug in my 2 for x to solve for the y. So we'll get 6 plus 4y equals negative 2. If we subtract 6 on both sides, we're going to get 4y is equal to negative 8. And dividing by 4 on both sides would give me negative 2. So my answer here would be 2, negative 2. That would be the point where these two lines, if I were to graph them, they would cross at the point 2, negative 2. All right? So that takes care of the first one. Now, if we look at the next one here, again, we're going to have to think of something we can multiply by to get these lines to cancel. And if I look at these two, it looks like the x would be probably the easiest one to get evil twins on. I already have a 2x up here, and there's something I can multiply this x by so that they'll cancel pretty easily. And you may already be kind of starting to figure this out here. Negative 2 is probably going to be our best bet if we multiply by. That would give me a negative 2x, which would cancel with the positive 2x when I add them together. So let me first multiply everything through in here by negative 2. So this will be negative 2x minus 10y is equal to, again, don't forget that last number, that would be negative 4. Little space here. And then over here we've got 2x plus 7y is equal to 1. Again, this I'm not going to change. That's already good to go. So 2x plus 7y is equal to 1. And from here, again, let's just kind of add things up. So 2x and 2x, this is what I want to happen. I want the 2x to cancel with that negative 2x. Otherwise, if I have two variables, I'm in trouble. This should be negative 3y is equal to, this would be negative 3 here. And then if I divide by negative 3 on both sides, I should be getting a y coordinate of 1. So let me sneak that down here. Now, for the point where these lines meet, to find the x coordinate, we should plug it back in. So I think we'll use the bottom equation here. So we'll use this one. X plus 5 times 1 is equal to 2. So x plus 5 is equal to 2. And if I subtract the 5 over, I should get negative 3 for the x. So that takes care of the second example there. So negative 3, 1. Now, if you look at this one, you might also find that here, there's no nice one single number. I could use a fraction and it would work, but there's no nice single number I can multiply one of these equations by to get evil twins here. It's not as easy as the other ones where I could just multiply the top or the bottom without using some sort of fraction or decimal. So what I'm going to do is I'm actually going to multiply both of these equations by something to get things to cancel. And you can really pick whichever one you think is easier. You could find a way to cancel these two, you could find a way to cancel these two. I'm actually probably going to try and cancel the b's because that'll make my numbers a little easier. So what I can do here, since -2 and 3, their least common multiple is 6. So if you think about, 2 and 6, 6 is the smallest number that 2 and 3 go into. So it's usually a good number to try and work with, your least common multiple. It keeps the number small, and it should help things cancel. But what I'm going to try and do is make this a -6 and make this a +6 so that things will cancel nicely for me. Now to make this top one a -6, I'm going to have to multiply everything in here by 3, because 3 times -2 gives me 6. If I want the bottom one, that b, to be a 6, I need to multiply everything in here by 2, because that 2 times 3 would give me a +6, and then I should have a negative and a +6 when I'm done here, which should help me solve this system. So let's sneak this in here. I'm changing now both the top and the bottom equation, so we're going to have to do a tiny bit more work here. So this will give me 27a, I'm just distributing the 3 into the top, minus 6b is equal to -24. And then on the bottom here, if I distribute this 2 in, I should get -14a plus 6b. Notice, this is what I want to happen. I want a -6 and a +6. We'll get our evil twins there. Equals +24. And now I'm all set to add these guys up. Okay, so if I do 27a's minus 14a's, that should give me 13a's. If we look at the -6b and the +6b, they eliminate, which is what we want to happen. That's good. And actually, these eliminate too. -24 and +24 cancel and give me 0. So from here, what I'll do is I'll divide by 13 on both sides, which gives me that a is 0. Okay, so we can see that a is going to be 0. Again, alphabetical order is the way to go for these. Even though they're not x and y, we're just going to put the a in the x position and the b in the y position, since that's how they appear alphabetically. And now from here, we'll plug in our a. Let's go to, I don't know, let's choose the bottom equation here. So we'll take -7 times 0 plus 3b is equal to 12. Okay, this will give me 0 plus 3b is equal to 12. Again, anything plus 0 stays the same. And then if I divide by 3 on both sides, we should be getting 4 for our answer there. Okay, so you might find that you don't have to multiply anything. Like in the previous video, part 1, we may not have had to multiply anything to get evil twins. We might have to multiply one of the equations to get evil twins, like we did in these first two examples. Or it's possible we might have to multiply both equations by something to get things to cancel. And again, it doesn't really matter which variable you cancel. There's going to be some that are easier, some that are more difficult. Actually, in this equation that we just did right here, I could have taken this equation, if I wanted to cancel the a's, I could have taken the top equation by 7 and the bottom equation by 9, and that would have given me a 63a and a -63a, and I would have solved for b first instead of solving for the a first. And it all works, so it's just, I think that 6 is an easier number to get to rather than, multiplying by 9 and or 7 are a little bit harder to do in your head. But anyway, so that's how you can solve a system using elimination. I'm probably going to talk about some special types of solutions in our next video, no solution and infinitely many, and how they appear in both substitution and elimination problems.